Hello, this is Mr. Huber. In this lesson, we're going to learn about applying exponent properties involving quotients. So some properties of exponents when there's quotients, which means division. If we look here, we have division, x to the fifth over x to the third. That means x to the fifth divided by x to the third, right? X to the fifth would be 5x's multiplied together. X to the third would be 3x's multiplied together. If we know about fractions, we can reduce fractions by canceling out common factors. We cancel out a common factor in each numerator and denominator, three of them. We're left with two x's in the numerator, which would be x to the second. So the rule for that would be we can subtract the exponents. So when we're dividing like bases, we subtract exponents. If you recall, multiplying like bases added exponents. Now when we divide like bases, x and x, we're going to subtract the exponents. The exponent in the numerator minus the exponent from the denominator. That's the quotient of powers property. Dividing like bases, subtract the exponents. And we have a quotient to a power. So here we have an entire fraction, quotient to a power. We can take each of the numerator and denominator separately to that power. So we can take x to the m power, then over y to the m power. And these aren't the same base, so we would leave our answer just as we see it there. Okay, because we can't do anything with this because it's not the like base, not x to the m over x to the n or something else. It's x and a y, two different bases. Okay, but that whole fraction can be raised to that power. Recall, if I had 1/3 to the fourth power, that'd be 1/3 times 1/3 times 1/3 times 1/3. That'd be 1 to the fourth over 3 to the fourth. Right? We can take each of the numerator and denominator times itself that many times. All right, let's see how we can apply this. So we see some practice problems here. You can try these on your own as well. There's some more coming up, so you'll have another chance to practice some of these. So this first one starts a little small. M to the seventh over m squared would be m to the 7 minus 2 would be m to the fifth. Next up we have 6 to the 11th over 6 to the fifth. That would be 6 to the 6th. And we're just going to leave it like that for now. We could express that and evaluate it as whatever 6 times itself 6 times is, but for now we're going to leave it using exponents. The next one, number 3, we have a fraction raised to a power, so this would be w to the third over 7 to the third, right? Each of the numerator and denominator to the third power. All right, for this next one, we can make that y to the 8th as y to the 8th over 1, right? Which would give us y to the 8th over y to the 5th. Which then would be y to the third, 8 minus 5. So y to the third, right? That y to the 8th would be in the numerator over the y to the 5th. And now we have x squared over y all to the 4th power. So we have to recall here what to do when we have a power raised to another power. So we have x squared to the 4th power. So we multiply those powers together. That'd be x to the 8th over y to the 4th. Okay, so we still have to remember some of those other properties we've learned outside of the quotient. So a power to a power, multiply those powers together. All right, before we see some more problems with exponents, a little trivia on ice here. The original name for the Detroit Red Wings hockey team. What was the original name for the Detroit Red Wings? It was the Detroit Cougars, and that logo there you may see on throwback retro type gear. They actually came from a team from the WHL, the Western Hockey League, which folded and sold its players. In the NHL, Detroit bought a team to start in the NHL, and they bought the players from the Victoria Cougars of the WHL, who had just won the Stanley Cup in 1925 in that league, so they became the Detroit Cougars. And they actually didn't play in Detroit in their first season. There wasn't an arena built, so they actually played their first season games in a rink in Windsor, Ontario, across the border there in Windsor in Canada. And they were the Detroit Cougars for a couple seasons before they actually became the Detroit Falcons in 1930 and then became the Red Wings in 1932. So a little history there of the Detroit Red Wings franchise, which started as the Detroit Cougars. All right, now let's do some more practice with exponents. So these might be some ones to try. Get a little bit more complicated than ones before, but good opportunity to see if you're understanding some of these properties of powers with quotients. So in the first example here, first problem, and pause this if you need to try these out before you check how you do on them. All right, and if you've tried these, we can see that the first one we should first simplify the numerator. 9 to the 4th times 9 to the 3rd would be 9 to the 7th over 9 to the 5th. That'd be 9 to the 7 minus 2 would be 9 squared, which if we're going to evaluate it would be 81. So again, depending on what we're doing, this as using exponents, so we could just leave it as 9 squared. All right. In this next problem, number 2, right below it, we have negative 2 to the 7th over negative 2 to the 4th. Keep in mind that negative 2 in parentheses, we want to keep it that way as negative 2 to the 3rd. And if we were going to evaluate that, that'd be negative 2 times negative 2, which would be 4, times the negative 2 again, which would be negative 8. Okay, so as it with exponents, make sure it's in parentheses negative 2 to the 3rd. And then this problem number 3, we have 2r over 3w to the 3rd. So let's start with that. We can have 2 to the 3rd. Don't forget we have to take that 2 to the 3rd. It would be 8. Or if you want to write it as 2 to the 3rd, that's fine. R to the 3rd over 3 to the 3rd, which would be 27 w to the 3rd, times w to the 5th over 16r. And now we can simplify this. We can see that 8 and the 16 can be simplified to 1 and 2. Right? The r's, we have r to the 3rd over r to the 1st. Remember, there's a 1 there that we don't have to write. So when we write this fraction out, that would be r squared, 3 minus 2. And then we'd have w to the 5th over w to the 3rd, which would be w to the 2nd. We can write the 1 there. If you want to write this 1 over here, you can. You don't have to. Okay? And then we'd have 27 times 2. So 27 times 2, which would be 54. So we have r squared, w squared over 54. In problem number 4, okay, we can take everything inside the parentheses to the 3rd power. So this would be 3 to the 3rd power, which would be 27, h to the 12th, over 5 to the 3rd power, which would be 125, y to the 3rd. And there's nothing we can do to simplify that, right? The h to the 12th, the y to the 3rd, those are different bases. We can't simplify that and subtract their exponents or anything like that. Okay, so keep in mind with quotients, when we're dividing like bases, we subtract the exponents. So for instance here, same bases, subtract the exponents. Here, when we multiply, we have to remember some properties of products. So when we're multiplying like bases, add exponents, power to a power, we multiply the powers together, like we see here, h to the 12th. And when we're dividing, okay, take everything inside the parentheses to whatever that power is. That 3 is applying to everything inside the parentheses. This 3 applying to everything inside the parentheses. And then simplify at the end. You should only have each base written one time to some power. Make sure you're paying attention to those properties you have and what we can do to actually take numbers to a power to evaluate that instead of writing it as a power, depending on how we want to give those final answers.